Assalamualaikum and hi semua. So let us continue on electromagnetic induction, part 1, Faraday's law. We have learned on how electric currents create magnetic field in chapter 5, which refers to current carrying conductor or long wire, circular coil and solenoid. But the issue is, could magnetic fields create or induce an electric current? So the answer is yes. Experiment did by Faraday and Henry showed that an electric current could be induced in a circuit by changing magnetic field. So I ulang, bila ada perubahan medan magnet, maka electric current boleh di-induce dalam litar. So we refer to figure A. In figure A, we have a stationary magnet close to coil connected to the ammeter. So of course there will be a magnetic field lines around the magnetic bar, but the bar is stationary. Dia pegun, dia tak bergerak, so the current will not be induced in a coil. But somehow if we have a magnetic bar, we bring the bar close to the coil, meaning that the magnetic field lines will be increased. So bila increase, akan ada change of magnetic field. So when we move the magnet towards the coil, so the magnetic field lines will be increased, therefore the current will be induced. But when we have a magnetic bar, we move away from the coil, so the current also will be induced sebab akan ada perkurangan dari segi magnetic field lines. So maknanya bila ada perubahan magnetic field lines, change of magnetic field lines, so the current will be induced in a circuit. Okay, figure C, we have current carrying coil, meaning that current carrying coil produce magnetic field. So when we move the coil towards near the coil connected to the ammeter, or move away from the coil, so there will be a change in the magnetic field, so the current will be produced in figure C. Okay, then for figure D, we also have current carrying coil, but then we connected to a switch, so that the polarity of the current can be changed. So for these two cases, all these two cases C and D also produce change in the magnetic field, so the current will be induced in the circuit. So apa persamaan untuk case AB dengan CD? So untuk case AB dengan CD, source dia je berbeza. Untuk A dengan B kita guna magnetic bar, C and D kita guna current carrying coil. So dua-dua source tu dia ada medan magnet. So bila kita move the magnet towards or away from the coil, so akan ada perubahan medan magnet, so the current will be induced in the circuit. So what can we summarize from the experiment? An induced current appears or can be detected in the coil only if there is relative motion between the magnet and the loop. Okay, greater motion, faster motion results in a greater current. But when we reverse the direction of polarity of the magnet, so the current will reverse. Dia akan deflect to another direction. Okay, then the current flows in the opposite direction. And the corresponding EMF to cause this current we call as induced EMF. Faraday's law of induction states that the magnitude of the induced EMF in a circuit is equal to the rate of change of the magnetic flux through the circuit. EMF equals to negative N, capital N is number of turns, and D flux over dt. So kita dah belajar flux dulu, cuma kita nak recall balik ni. Magnetic flux is proportional to the strength of magnetic field B passing through the plane of a loop of wire and the area of the loop A. The SI unit is Weber or Tesla meter square. So magnetic flux is a scalar quantity. So maknanya dia adalah jumlah medan garis-garis medan yang melalui plane, yang melalui surface of the coil. Alright, so dia punya formula apa dia? Flux equals to BA cos theta. Okay, so maknanya nanti kita tengok dia punya kedudukan surface dengan normal of the surface. Kita refer figure sebelah kiri. We have magnetic field lines downward. Dua-dua figure tu downwards. Yang sebelah kiri kita ada loop, kita letak horizontal. Meaning that plane dengan B sekarang ni dia adalah perpendicular to each other. Alright, tapi normal. Daripada plane surface horizontal tu, kita dapat normal line dia 90 degree. So normal line, normal of the surface sekarang ni dia parallel to B. Tapi plane, surface plane tu adalah perpendicular to B. So theta dia adalah sudut di antara normal to the B. So that's why theta di 0. Tapi untuk belah kanan, kita ada surface, kita ada plane of a loop. Kita letak dia parallel to B. Parallel to B. Alright, tapi normal dia mesti 90 degree. So normal dia adalah perpendicular to B. A is perpendicular to B. So that's why theta dia 90. So yang ni kita recall balik, kita dah belajar itu. Alright, so hati-hati. So the angle theta tu adalah angle between A and B. A tu kat mana? A bukan surface. A adalah normal to the plane. Example 6.1. A coil of wire consists of 20 turns. So N dia 20. Each of which has an area of 0.0015 meter square. So area dalam SI unit dah ni. A magnetic field is perpendicular to the surface. Maknanya kalau B dia ke kanan, plane dia sekarang ni dia perpendicular. Initially, the magnitude of the magnetic field is 0.05 Tesla, and 0.1 second later it has increased to 0.06 Tesla. So yang ni B final lah. Find the average EMF induced in the coil during this time. So kita guna Faraday's law, equals to negative N d flux over dt. So flux apa dia? Flux adalah BA cos theta. Alright, so yang berubah apa dia? Yang berubah cuma B. So A cos theta tu constant. So then you substitute the value which are given in the example, then you will get the answer.